Hey guys, in this video we are going to talk about some concepts of Euclidean geometry. So let's start with some definitions. When we talk about geometry, we're talking about things like points and lines and planes. And everything's really made up of points and lines. So a point, we're going to notate by just dots. And if we connect those two, then we have a line. Now notice this line has arrows, in both directions. That lets you know that it keeps going on forever and ever. So if I want to think about how can I write that using mathematical shorthand, I can call a line by 2 points on it, and I notate it's a line by drawing a line with the little arrows above it. Now that's different than a segment or a ray. So a ray starts at one point and then it continues through another point. And it's just going to keep going on and on and on forever. So this ray starts at A and goes through B. Notice the way that this is written. So A, B, and it goes through B with that little arrow tip on the end of that. You can see that when I zoom in. So if I would have had a line segment, let's say here's A and here's B, and maybe it goes the other way. So it starts at B and goes through A. So I could write it that way, or some textbooks I have seen will write it this way, just changing that direction of the arrow. But notice that that arrow is going through A here. It has to show it's going through A here and it's starting at B in both of those notations. When we talk about a line segments do not go on forever and ever. They have a beginning and an end. So this one starts at A and ends at B. Okay, or we could say it starts at B and ends at A. Either way, it has endpoints at A and B. Notice the notation here has a bar over it. It does not keep going. So let's look at some examples. X, Y, and Z are points that's on this line, L. And if we know XY is equal to 9, and we know YZ is twice XY, we want to find the distance from here to here. So we could say XZ is equal to XY plus 2 times XY, because they told us this is 2 times that. Now, in this case, we know that XY is equal to 9, so we could say this is 9 plus 2 times 9, which is going to be 27. So that distance from here to here is going to be 27 because this is twice as long as this. So if this is 9, this has to be 18. So we could add it all up to get a total of 27 from end to end. Okay, now keep in mind, that's from this endpoint to this endpoint. That is not the length of the line that goes on indefinitely. It's just from X to Z. Plane is a flat surface that has no thickness and no boundaries. And a plane keeps going on and on in all directions forever and ever. And we can create figures using points and lines and planes. And a desk is a good example because you could think about this being a plane, but it's a finite plane because it's just a little piece of one. Same thing with this side and then the top and then even the back. Lines in a plane can be intersecting or parallel. If we have two lines that are intersecting, then they have to cross at some point in the plane. And we see this all the time with road maps, where we have roads that are crossing each other at some kind of point. Parallel lines are lines that never intersect, and the distance between them is always going to be the same. So we could think about railroad tracks. The distance between the railroad tracks here is going to be the same as the distance here. And these lines are never going to intersect or cross each other. We can show lines are parallel using the parallel symbol in math. So here we could say line AB is parallel to CD. And they're just talking about the segments here. Notice the notation above the AB and the CD. Now let's talk about angles. An angle is formed by taking two rays and connecting them at the same endpoint. So we would have this ray and then we would have this ray, and when we put them together, it creates an angle. So we could talk about the side of the angle here and here, and they meet on this vertex. And then we could talk about the measure of the angle. And usually we talk about that measure in degrees. So how do we name angles? So there's a few ways we could do it. So with this one, this is a really simple angle. I don't have extra things going on here, so I don't have a figure like this going on. I have just a really simple one angle. So I could talk about this as just angle B, and I'm going to use this symbol for angle, so I don't get it mixed up with a greater than or less than sign. I could name it from here to here to here, where that vertex is in the middle. So I could call it angle ABC, ABC. If I wanted to, I could even go CBA, as long as that vertex is that middle letter. So if the lines get more complicated, so if we had something that crossed like this, then this would not be useful. We would not do that. Let's say we were talking about this angle here. If we just said angle B, well, we wouldn't know, the reader wouldn't know which B you're talking about. Are you talking about the top, the bottom, the right, or the left? And if this is the one you were referring to, that wouldn't be useful information. We would have to go with the three-letter option to name this. We would say EBD or DBE. So it depends on how complicated the picture is. But with this one, since there's just one angle at B, we could go with any of those three options. So an angle can also be named by a variable written between the rays. So like in this picture, we have, excuse me, we have an X written here between these two rays, and then a Y written here between these two rays. So we could call this angle X. It would be really clear that's what we're talking about. And we could call this angle Y. We could not just say angle R in this case, because again, which one are you talking about? Are you talking about this or are you talking about this? So that would not be a good option. So we could say angle X, which represents QRS, or Y, which represents SRT. Usually when we talk about angles, we talk about them in degrees. There is another measure for angles, and it's called radians. But most of the time we talk about things in degrees. So to show that we're talking about degrees, you're going to use the little degree mark. So if we're talking about a circle, there are 360 degrees in a circle. This little circle where an exponent would be tells me that you're talking about 360 degrees. 90 degrees is called a right angle, and you can see the mathematical shorthand here by using that little box inside of that angle to denote that that's a right angle. Perpendicular lines are lines that are going to intersect at right angles. So this line AB intersects CD, and notice they've got that denoting a right angle here, which means that these are perpendicular lines. And we see perpendicular lines all the time. Your wall is going to be perpendicular to your ceiling in your house. Same thing, your wall is perpendicular to your floor in your house. So we see perpendicular all the time. The shorthand for perpendicular is using that little upside down T looking shorthand notation. Straight angles are angles that measure to 180 degrees. Complementary are angles that measure to 90 degrees. So these two would be complementary because 60 degrees plus 30 degrees would equal 90 degrees. Supplementary angles are two angles who measure to 180 degrees. So angle C and angle D are supplementary because they add up to 180 degrees. Acute angles are angles that measure between 0 and 90. Obtuse are going to be between 90 and 180. So this is obtuse, whereas this is acute. So let's say we have the measure of angle C, which is 110 degrees. So we know this is obtuse. So this is C. We would say the measure, notice that M there, of angle C is equal to 110 degrees. So that's a shorthand way of saying that sentence there. Let's look at an example. We want to find the measure of the complement of 38 degrees. So we know complementary measure angles have to add up to 90 degrees. So some measure plus 38 has to equal 90. And if we subtract 38, we'll get that measure. So 90 minus 38 is 52. So it would be 52 degrees. Adjacent angles are angles that are side by side. They share a common side here. So angle DAC is adjacent to CAB. And notice that these are adding. We could talk about the sum. So if this is 45, so if we know angle DAC is 45 degrees, so the measure, and then the measure of CAB is 55, then we could find the measure of DAB. The AB would be the sum of those two. So 45 plus 55, which would add up to 100 degrees. Let's look at an example. Given that measure of ABC is 84, so this whole thing's adding up to 84. We want to find the measure of X. So we know the measure of angle X plus the measure plus 47. We already know that. I'm just going to type in the 47. Has to equal 84. So if I subtract the 47, then the measure of angle X has to be 84 minus 47. Which is what, 37 degrees? So this has to be 37 degrees for these to add to the 84. So now let's look at angles that are formed by intersecting lines. 4 angles are formed by the intersection of 2 lines. So if we take 2 lines and we intersect them, we're always going to get 4 angles. You can see here, 1, 2, 3, 4. If the 2 lines are not perpendicular, then 2 of them are going to be acute angles, and the 2 of them are going to be obtuse angles. And the 2 acutes are always going to be opposite each other, so we call these vertical angles. And these 2 obtuse are going to be opposite each other, and they are vertical angles. So the measure of angle 1 is going to be equal to the measure of angle 3, and the measure of angle 2 is equal to the measure of angle 4. Now, if the 2 angles are side by side, they form a straight angle, which is going to add up to 180 degrees. So in this figure, W plus x would add up to 180 degrees. Y plus z is going to add up to 180 degrees. And then we could look at them this way too. X and y, and then w and z would both add up to 180. Same thing here. 2 and 1 would add up to 180. 1 and 4 would add up to 180. 3 and 4 would add up to 180. And 2 and 3 would add up to 180. And we can use that to help us solve problems. So let's look at this figure. We know the measure of angle B is 115. They want us to find the measures of the other ones. So if this is 115, then that here has to be 115 because they are vertical angles. And then we know these two have to add up to 180. So 180 minus 115 would tell us what this is. So this one has to be 65 degrees. And if this is 65 degrees, then this one would have to be 65 degrees as well. And we can make this a little bit more interesting by talking about parallel lines and then cutting it by what's called a transversal. So if L1 and L2 are parallel lines, then we're going to have 8 different angles. And there's relationships between those angles. We're going to have alternate interior angles. So if we look at D and X, these are going to be alternate interior angles. They're going to have the same measure. C and W are the same way. You can see that here. And then we have alternate exterior angles. So if we look at A and Y, let me do this in a different color. A and Y. Okay, notice they are on the outsides of the parallel lines. They're alternate exterior angles. So they're going to have the same measure. B and Z would also have the same measure. So you can see all these relationships forming. And then once again, we could talk about adjacent angles. So C and D form a straight line. So they have to add up to 180. W and X form a straight line. They have to add up to 180. Oops. So that would help us figure out all the different types of angles that we have. And then we have corresponding angles. A and W are going to be corresponding. So A and W. Let me use a different A and W. Okay, notice they're on the same side. But they're going to be corresponding, which means they have the same measure. C and Y is going to have the same measure. B and X would be corresponding, and so on. So let's solve a problem. And what that means is we want to find the measure for all the different angles. So we know measure F, the measure of angle F is 58 degrees. So if this is 58 degrees, then that means H has to be 58 degrees because they are vertical angles. And then I also know that F corresponds to A, which means this has to be 58 degrees, which means C has to be 58 degrees as well. And then now let's figure out what one of these other ones is, because once I know one, I'm going to know them all. It's going to work kind of like dominoes. I know that these two have to add up to 180. So if I take 180 and I subtract the 58, that's going to tell me what this obtuse angle is. So 180 minus 58 is 122 degrees. So this has to be 122 degrees, which means D has to be 122 degrees because it's a vertical angle. And we know D corresponds to E, so E has to be 122 degrees. And that means that G also has to be 122 degrees. And then now let's talk about angles of triangles. So we could take 3 lines and we could form a triangle. And we're really concerned with this area in here. So it turns out that all of the interior angles have to add up to 180 degrees. So if we call this A, B, and C, the measure of each has to add up to 180. So that's going to be the sum of the interior angles. When we talk about the exterior angles of a triangle, and the exterior angle is the angle that is adjacent to an interior angle of the triangle and is supplemental to the interior angle. So here's my triangle in here. A is an interior angle. And you can see how these are lines, so they keep going. So M would be an exterior angle, and same thing with N. And those are vertical angles, so we know that they're going to have the same measure. We also know that measure of A and M, that's forming a straight line, so it's got to add up to 180 degrees. So let's look at an example. Two angles of a triangle measure to 43 degrees and 86 degrees. Let's measure up the third angle. So I'm going to draw a picture. This picture is not going to be the scale, and that's okay. So we have 43 degrees for one. We have 86 degrees for the other. We want to know what this one is. So we know they have to add up to 180. So I'm going to take 180, and I'm going to subtract the 43, and I'm going to subtract the 86. And then I'm going to get 51 degrees. So this has to be 51 degrees. All right, let's look at this last one. So we know the measure of angle C is 40 degrees, and the measure of angle E is 60. We want to know what D is. So let's see if we can figure that out. So this is 60, and it is across from A. Then A has to be 60 because it's the vertical angle. We know that, so we know A is 60. We can find B because we know that these three angles, ABC, have to add up to 180. So 180 minus 60 minus 40 will tell us what B is. So angle B equals 180 minus 60 minus 40, which is 80. So we know this is 80 degrees. And we know these two have to form a straight line, right? So we know that B plus D have to equal 180. And if B is 80, then we know D has to be 100. So D has to be 100 degrees. So we can use all that different information to help us solve different figures and find the measures of all of our angles.